everyone. Welcome to the EL Weekend Digital Learning Studio here at Museum of the Rockies. My name is Ashley Hall, and I'm your host of Fossil Friday and the Outreach Program Manager here at the museum. Now today, we're gonna be doing a whole Fossil Friday dedicated to tyrannosaurs, one of the most awesome groups of dinosaurs and one of our favorites here at Museum of the Rockies because we have the biggest collection of Tyrannosaurus rex fossils in the world. Join me as we dive right in, or should I say, bite right in to our Fossil Friday today, all about Tyrannosaurus rex growth. Let's go. Today, we're going to be talking to you about the Tyrannosaurus growth series on display at Museum of the Rockies. These beautiful fossils are on display in the Hall of Horns and Teeth exhibit. The smallest skull on the left is called Chomper and represents a very young juvenile life stage of a T-Rex, which is between 1 and 2 years old. The second skull is a replica of the dinosaur commonly known as Jane. Jane is considered the most complete teenage Tyrannosaurus rex ever found. The real fossil is on display at the Burpee Museum of Natural History in Illinois. The third skull is nicknamed B-Rex, and studies have shown that it is a mature subadult female T-Rex that is between 16 and 20 years old. The final skull is known as Montana's T-Rex, formerly known as Pex Rex, and it was a fully mature adult T-Rex between 22 to 30 years old. So what are tyrannosaurs? Tyrannosaurs are a fairly diverse group of theropod dinosaurs characterized by their large heads, strong jaws, large and massive knife-like teeth, short arms with 2 fingers on each hand, and robust bodies. They lived from 86.3 million years ago to 66 million years ago, and there are now approximately 20 tyrannosaurid genera or groups known from this clade. So on the screen there, when you look at the slide with all the tyrannosaurs on it, you can see the cool diversity where there are some that are really small to those really enormous tyrant lizards that we all know and love, right? Things like Tarbosaurus and of course T-Rex. So that begs the question, when did tyrannosaurs evolve? Tyrannosaurids, or early relatives of T-Rex, first evolved 167.7 million years in the Middle Jurassic period. These tyrannosaurs remained mostly small in body size and ecologically minor in their environment until the late Cretaceous period. The clade Tyrannosauridae didn't evolve until the beginning of the late Cretaceous, 87 million years ago. The 2 subfamilies, Albertosaurinae and Tyrannosaurinae of Tyrannosauridae, showed up at this time, 87 million years ago. So tyrannosaurs lived for a very long time. But T-Rex, as we know and love them, only lived for 2 million years at the very end of the Cretaceous period, right before that main extinction, 66 million years ago. So let's think about deep time for a minute. Millions of years is really hard to imagine, but we as people right now are closer in time to T-Rex than T-Rex was to Stegosaurus. Mind-blowing, right? T-Rex lived 66 million years ago, and Stegosaurus lived 150 million years ago. That's 84 million years separated. We are 66 million years separated from T-Rex. So, chew on that for a while. That's pretty wild, right? Where do you find T-Rex fossils then? Only in North America along the prehistoric coastline of the Western Interior Cretaceous Seaway. Now, the seaway doesn't exist anymore, but Tyrannosaurus rex fossils have mostly been found in Montana, where we are, North Dakota, South Dakota, Wyoming, Alberta, and Saskatchewan, Canada. So, we know where their fossils were found, but what was the Hell Creek ecosystem like when Tyrannosaurus was alive? The Hell Creek Formation is among the few geologic units worldwide that represent terrestrial environments at the end of the Cretaceous. The Hell Creek Formation is late Maastrichtian in age, 68 to 66 million years old. From fossils, this environment is interpreted as an expansive, fluvial, drained, low coastal floodplain that was against the transgression of the Western Interior Seaway. It had meandering river systems and was a very warm, humid, and swampy climate that housed numerous types of plants, such as angiosperms or flowering plants, conifers, ferns, ginkgos, and cycads. Rich plant life helped to support invertebrate faunas, including crocodilians, turtles, pterosaurs, birds, fish, mammals, lizards, and dinosaurs such as Triceratops, Edmontosaurus, Pachycephalosaurus, Ornithomimus, Ankylosaurus, Leptoceratops, Anzu, Dakotaraptor, Acaroraptor, Denversaurus, and of course, Tyrannosaurus rex. With its warm, swampy environment and rich biodiversity, the Hell Creek ecosystem was very similar to the swamps of Louisiana and the Florida Everglades. Just take the Florida Everglades and drop in Tyrannosaurs, Triceratops, and all those cool dinosaurs, and you've got the Hell Creek ecosystem. What makes Tyrannosaurs so well known? Well, I bet you guys can guess, and it has to do with Jurassic Park. Tyrannosaurus rex is arguably the most famous large carnivorous dinosaur of all time. It's in many of our favorite TV shows, movies, books, and toy playsets. T-Rex is everywhere, but not many take the time to learn more about it. T-Rex is the largest species of tyrannosaur to ever live, and it grew to 40 feet long, which is longer than the length of a school bus. The skull of a fully grown Tyrannosaurus rex is 5 to 6 feet long and was full of massive, powerful teeth the size of a banana. Now, when fully grown, Tyrannosaurus rex had the strongest bite force of any land animal at 7,800 pounds. That's the equivalent of 3 full-size cars landing on you all at the same time. And that is a really strong and scary bite force. Evidence of its bone-crushing bite can be found in its coprolites, or fossil poop, in the form of bone fragments. We suspect that this coprolite is from a T-Rex because it was discovered in the Hell Creek Formation near where previous T-Rex fossils have been found. The bone fragments discovered inside show signs of the bone being digested by stomach acid. The photo on the screen depicts the largest fossil coprolite found, and it has been named Barnum after Barnum Brown, the first paleontologist that found and described Tyrannosaurus rex in 1902. This coprolite is 26.5 inches long, which is 2 feet 2 inches and 6.2 inches wide, and weighs about 20 pounds. That is the same size as a full-grown beagle. They get to be between 20 to 25 inches long and about 20 to 22 pounds. Tyrannosaurus rex's feet and footprints were absolutely huge. The footprint of this large dinosaur is almost 2.5 feet long, or 31.5 inches. And this image here depicts the life-size Tyrannosaurus rex footprints made in the sand on the beach in Wales. They were made by sand artists and paleontologists to help celebrate the launch of the new dinosaur documentary, Prehistoric Planet, narrated by Sir David Attenborough on the streaming service Apple TV+. So the most noticeable feature of Tyrannosaurus rex is its tiny arms. While T-Rex's arms may look really tiny on their really big bodies, their arms are actually the size of a whole human arm. They were also surprisingly muscular and able to lift about 400 pounds. Paleontologists hypothesized that their arms had many different functions, such as holding on to prey while hunting, using in mating or courtship, or being able to help push themselves up off the ground from a sleeping position.
Can't see us if we don't move.
Tyrannosaurus rex is very different from how the Jurassic Park film franchise depicts it. Tyrannosaurus rex, unlike the film, had amazing eyesight, and it was able to see you if you moved. And studies show that T-Rex had amazing binocular vision similar to modern birds of prey. It also had a highly developed sense of smell and hearing. So, because of science, we now know if you stand still, it can still see you and smell you. So, if you happen to go back in time and meet a T-Rex, be sure to run away as fast as you can. Why is learning about how T-Rex grew important? Tyrannosaurus rex was not born a massive predator capable of bone-crushing bite. Just like every living thing, T-Rex started small and it went through various growth stages as it aged. When T-Rex was young, its skull was very long and narrow with slender knife-like teeth in its mouth, large eyes, and a smooth-looking snout. A long, slender body with long, slender arms. As T-Rex matured, its skull got larger and bulkier, its teeth got larger and more robust, and the top of its snout became more gnarled, and horn-like projections made of keratin started forming over the eyes. Its body became longer, thicker, and heavier. Previous studies have estimated that T-Rex grew at almost 2.5 kilograms or 5.5 pounds per day. There is still so much to learn about these fossils, but what we've learned so far has bettered our understanding of Tyrannosaurus rex and its relatives. All right, so now it's time for our Fossil Friday close-up. This is the part of the show where we get to show fossils from our collection up close and personal. So today I brought some really special fossils to share with you, and I want to start with this one right here. This is Chomper, the 1 to 2 year old baby Tyrannosaurus Rex that was found by Lee Hall in 2010. This is actually a 3D print, a 3D copy of the actual specimen. Now, when Lee found the original specimen, it was only a fragmented piece of a jaw with a little part of a tooth inside, but it was enough to say that it was for sure a baby Tyrannosaurus Rex. So you may be wondering, how did we get this entire skull just based off of a tiny fragment of jaw? And that's a great question, and it's being done more and more in paleontology. We took the tiny jaw fragments and sent them to Dr. Larry Whitmer at The Ohio University, and he took these tiny fragments and reconstructed an entire skull based on looking at other juvenile or baby tyrannosaurs. Dr. Larry Whitmer reconstructed Chomper based off of Tarbosaurus, a tyrannosaur that lived in Asia, and Gorgosaurus, a tyrannosaur that lived in Canada. The outcome was that we have a full-size skull of a tiny baby tyrannosaur found right here in Montana. Now, the next fossil I'd like to show you is of a full-grown T-Rex tooth. This is always my favorite thing to take out because look at how massive this tooth is. It starts down here at the very tip, and then all the way up here is the root, the part that goes inside of your mouth. So when you smile, the part that sticks out is only this part on Tyrannosaurus Rex, and that's pretty small. Now, why does it have such a really enormous root? Well, that's because these guys were bone-crushing animals. They were biting into these enormous animals like Triceratops and having to sink their teeth in, and so they needed a really big, strong root to have their teeth not fall out all the time. And if their teeth fell out, this right here, this part that has this sort of indentation, is where the next T-Rex tooth would be growing in. So unlike you and me, once we get our adult set, that's it. We have to brush them and take care of them and go to the dentist. But with T-Rex, they fell out and grew back in again. So no cavities for T-Rex. Now, I brought a couple really cool things to show you today. I know my table is full of cool things, but I brought 2 real teeth. I brought a tooth of a baby Tyrannosaurus, so it's a really cute little tiny baby tooth. So this would be like the size of Chomper here. So you can see it's pretty much the same size as a 1-year-old T-Rex. And then I also brought a tooth from Pleistocene, which is a 75 million year old tyrannosaur found here in Montana. And I'll make sure we get a nice close-up for you guys to see here of the serrations. This is a tooth from Pleistocene, which is a 75 million year old Tyrannosaurus, related to Tyrannosaurus Rex, but 10 million years older, which is so hard to imagine. But this tooth is really similar to T-Rex as it's really thick. So if we see that cross section there, it's really thick and not blade-like. And it also has serrations on the tooth, which are these tiny little bumps that make the tooth very sharp. Now, ask a parent or a guardian to get a steak knife or a butter knife out from your drawer because you can see the same very serrations, these tiny little bumps, on a steak knife or butter knife at home. Our next fossil, this is a maxilla, so the upper jaw of Pleistocene. And with this one, you can see here, it's got the tooth sockets. And you can see there that the teeth are actually all fallen out, except for this one here that's still coming back in. So again, tyrannosaurs replace their teeth their whole entire life. And on a lot of tyrannosaur jaws, when you see their teeth that are sort of jagged, and I'll show this one here to demonstrate that. So this one right here, you can see that they have sort of like a short tooth and a long tooth and a short tooth, right? Kind of back and forth. That's because these animals are growing teeth in their whole entire lives. So when you see that beautiful smile of a tyrannosaur where it's got these kind of long, jagged teeth and short ones, it just means that they're regrowing those teeth. All right, everyone, thank you so much for joining us on today's Fossil Friday. Join us on Select Fridays live, which is how the Fossil Friday format usually is. And you can interact with me, you can ask questions in real time, and you can do so by visiting museumoftherockies.org/virtual programs. So please tell friends, parents, educators, anyone who loves fossils, and we'll see you live on Fossil Friday.